Good afternoon, New York, and the rest of our listeners around the globe. My name is June Stoyer, and I'm the host of the Organic View radio show. Our podcast is available on iTunes, Zune, and you can also visit our website at www.theorganicview.com. If you'd like to be on the show or would like to find out about sponsorship opportunities, please contact us at questions@theorganicview.com. Today's show is sponsored by Eden Foods, the most trusted name in certified organic clean food. When you shop online at edenfoods.com, enter the coupon code ORGVIEW to receive 20% off any regularly priced items, excluding cases. For other promotional offers, please visit theorganicview.com's website. And don't forget to check out our contest section.
Global warming is of great concern because of the impact not only on the ecosystem, but on human health. There have been many concerns about how the increasing climate change will impact our crops. This is a huge concern because if we are unable to grow enough food, we will not be able to feed the world's growing population. World-renowned authority, Plant Physiologist Dr. Louis Ziska has done extensive research on this very subject. On today's show, we're going to be discussing whether or not climate change really has an actual impact on crops as well as invasive weeds. And can anything really be done to safeguard our food? Then there is the question of adaptation versus mitigation. Is this even a viable option? Dr. Ziska is a plant physiologist with the USDA's Agricultural Research Service in Beltsville, Maryland. After graduating from the University of California, Davis, he began his career as a Smithsonian Fellow and then took up residence as the project leader for global climate change at the International Rice Research Institute in the Philippines before joining the USDA. Dr. Ziska has published numerous papers on carbon dioxide and climate change impacts on agriculture, weed biology, and public health. At present, he is investigating the role of rising carbon dioxide and changing climate on food security, invasive species, and aerobiology. Dr. Ziska's research has appeared in numerous publications such as the Wall Street Journal, National Geographic, New York Times, USDA, Washington Post. He's been pretty much in every major publication and has even appeared on NBC Nightly News with Charles Gibson, NBC Nightly News with Brian Williams, and he was also featured in the HBO documentary Too Hot Not to Handle. So I would like to welcome to the Organic View Dr. Louis Ziska. Dr. Ziska, good afternoon and welcome to the show.
Good afternoon, June. Thank you so much for having me on.
Dr. Ziska, can you tell our audience about yourself? I just read a brief biography about you, but you have such an amazing background. I think our audience will definitely appreciate everything that you've done as far as your research and your entire academic background.
Well, it's been, as I say, a pretty spotted past that I have. I started out with the Smithsonian back when they were doing a pilot project looking at how climate change and specifically how rising carbon dioxide was going to affect marsh ecosystems. And so I did this for the Smithsonian out and the Environmental Research Center, which is on the western side of the Chesapeake Bay. And following that, I had been working on various aspects of climate change, everything from the change in the ozone level to how rice will respond to CO2 and temperature. And I've been doing this since 1989. So I was back doing climate change, if you'll pardon the pun, when climate change wasn't cool. So I've seen a lot of sort of new and different information that's come along. But I've also gotten a chance to see what the projections have been. That is, back in the late 1980s, early 1990s, when we were looking at the models, when we were getting a sense of, well, how much of a problem is this going to be? What sorts of impacts can we expect with respect to plant biology, particularly with respect to ecosystems and managed ecosystems like agriculture? And I've seen so much of that actually happen. That is, the predictions that we had have actually come to a large extent have come true. So I think that when you start looking at the issue of global climate change, and there seems to be this disparity between the scientific world, where the consensus is pretty overwhelming. I think 98% of all climate scientists agree that this is climate change, and has been for quite some time. You can actually go back and look at the number of peer-reviewed papers back even in the 70s. There were actually more papers published about global warming in the 70s than there were about global cooling. So there is this sense of time having passed and those predictions coming true. And when you look at this issue, I think it's important to sort of get a sense of why that disparity exists. Is you have the increasing confidence of the scientific community, but at the same time, the general public seems to be more and more confused about what climate change or global warming really is and what the impacts of that really are. So if it's all right with you, let me do my very quick, hopefully understandable explanation of what climate change really is. Is that
sure,
okay?
That would be great. Because I think, especially if we can clarify from your perspective, and you're the authority, people can finally understand for once what exactly it means.
Well, it's pretty simple. When you burn fossil fuels, that is, when you take oxygen and you combust a fossil fuel in order to produce energy, the byproduct of that is carbon dioxide. And since we've been working in the fossil fuel generation, that is, from about the late 19th century to today, we've generated all this additional CO2 that's going into the atmosphere. And what CO2 does, actually, is it is what's called a global warming gas. Now, what does that mean? Well, the best example I can give to you is for any of you who have played the guitar or any stringed musical instrument. I didn't back in high school because I was trying to impress girls. But what you would do is you take a guitar, and being the nerd that I was, I would tune two of the strings of the guitar to the same key, let's say the key of A. And I would hit one string. And when I did that, the second string would start to resonate. Okay, it would absorb some of that energy from the first string. And really, that's the phenomenon we're talking about with global warming. Now, we're not talking about it in terms of music, but we're talking about it in terms of CO2 and water vapor and nitrous oxide and molecules, because they also resonate, just like those guitar strings. They resonate not in the key of, say, A at 440 hertz, but they resonate in the key of heat or infrared. And because whenever heat passes that molecule, it resonates and it absorbs some of that energy. And that's a great thing, because without that, the Earth would be much cooler than it is today. So that is, in fact, part of the natural greenhouse effect. But as you add more and more of these chemicals to the air, if you use the atmosphere as essentially an open sewer, what happens is that over time, the buildup of CO2 and other greenhouse gases from human activity will result in a surface temperature change. Now, that's the easy part. If you actually look at the globe as a whole, one of the questions that will occur to you is, well, if this is going on, why isn't everything heating up really fast all at one time? And the answer to that is actually you have to understand the other big greenhouse gas, and that's water vapor. So if you look at the relationship between CO2 and water vapor, that explains 99% of what's going on. For example, if you look at the globe as a whole, where is it warm and humid? That is to say, where is the water vapor concentration high? Well, it's high at the equator. So adding CO2 doesn't do much for the equator, because at the equator, water vapor is the dominant greenhouse gas. So we don't expect to see a big change at the equator. Now, for those of you that still think the sun is responsible for global warming, that should be a kind of a clue right there that it probably isn't. Because if, in fact, the sun were the thing that was driving global warming, then the temperatures at the equator would be going up much faster than they are at the poles. But in fact, it's the opposite. The pole temperatures are going up much faster than the equatorial temperatures. Now, why is that? Well, because, again, of this relationship between CO2 and water vapor. When water vapor is low, CO2 has a bigger effect. When water vapor is high, it has a smaller effect. So we've seen the smaller effect for the equatorial regions, but where it's cold and the air can't hold a lot of water vapor, now we see that CO2 is having a bigger effect. So this is why the warming that's going on at the poles is so disproportionately higher. Well, we can take it another step. Where else in the world is the air dry? It can't hold a lot of water vapor. Well, deserts. So again, we expect to see increased desertification. Where else? Well, seasonally, we know that winters are, in fact, that don't hold a lot of water vapor. The air is dry during the winter, therefore winters should warm faster than summers, and so on and so forth. But it's that disparity between what areas are heating up and which areas are not, which is in fact driving this global process of increasing storms, of increasing extreme events, where 1 in 100-year events are now becoming 1 in 10-year events. That's the sort of two-pronged attack, if you will, where you have this increase in these global warming gases. The increase is disproportionate. It's driving different temperatures or different areas of the globe at different temperatures, and that's that discrepancy in temperature that's driving these extreme storm events. Now, that's sort of hopefully a very straightforward explanation of climate change and global warming. I don't know anyone, any climate person who disputes that man-made or human activity is in fact responsible for this to occur. If you think it's something like the sun being warmer, then in fact you would see the opposite effect. Again, the temperatures at the equator would be warming up faster because that equator gets much more sun than the poles. In fact, we see, again, the opposite. So it suggests very strongly that it isn't the sun that's driving this. It is, in fact, this buildup of global warming gases that's causing these things to occur. So the other effect that is important to recognize in climate change, and it's one that doesn't get a lot of attention, is that CO2, the increase in CO2 of and by itself, will have a huge impact in terms of biology. Why is that? Well, it turns out that plants, or at least 95% of all plants, evolved at a time when the CO2 concentration was much higher than it is today. So as the CO2 increases, they're getting more of an essential resource. So in fact, the plants will respond positively to that increase in CO2. So many of the folks, and particularly in the fossil fuel industry, look at this and say, oh, this is wonderful, this is going to be great. It's more complicated than that. And the real question you have to address is which plants are going to respond more to that change in CO2. And here it's where it really gets interesting, and there's so many different scientific ramifications of that. So that's the overall background. You have two major effects, the change in surface temperature and the change in the increased intensity and frequency of major odd events in terms of what I think Tom Friedman called this morning in the New York Times global weirding. And the other aspect of this is that CO2 of and by itself will have an effect on plant biology. That's important because all life in turn depends on plants. We couldn't exist without them. So what does this mean? I mean, what does it mean in terms of the general aspects of plant biology? Well, if you start looking at the thing you mentioned earlier, you were talking about food systems, I think. There are all kinds of implications with respect to that. We have, I think at present, a little over 7 billion people in the world. And that just boggles my mind because when I was born, way back in the dark ages, there were less than 3 billion people in the world. So we've more than doubled the population just in my lifetime. In fact, at current population rates, we expect to see about 1 billion people every 15 years or so. It's about 200,000 people per day if you want to do the math. So what do we do with all these extra people? How do we feed them? Well, how do we feed the 7 billion that we have now? Well, we're able to feed them based on what's called the Green Revolution. And this was a scientific, enormous revolution, again, very much underappreciated, that allowed us to choose the certain varieties of cereals, because the world runs on cereals, like corn, wheat, and rice. That's 50% of your food right there. And what allowed, the Green Revolution allowed those crops to be grown with large increases in yield because they found the varieties that would respond to water, that would respond to fertilizer. And man, those yields just took off. Do you remember when you were a kid? I don't know how old you are, June, but as a kid, my parents would always tell me, eat your veggies, because Lord knows there are starving children
in Ethiopia.
Starving children in China, starving children in India. And, I kept thinking, if I could only send them my Brussels sprouts, just get them out of my plate. But what happened with that then is that 10 years later, it was in fact India and China that were major exporters of food, and that's the Green Revolution. It's the ability to grow large amounts of food in a small space because you could find those varieties that would respond to cheap water in the form of irrigation, cheap energy in the form of fertilizer. And there's one other thing that doesn't get mentioned a lot with the Green Revolution, and that is in order to do all that, you have to have a stable climate. Aha. The reason you have to have a stable climate is that if I'm a farmer and I have 1,000 acres of wheat, I have to grow the same variety of wheat for very strong economic reasons. That is, I can't grow 100 different varieties of wheat. I would be crazy to do so because I'd be out there harvesting all the time, right?
Well, you have to grow what is going to work with the environment that you have, and also something that is going to be consistent. But my question is, with the temperature in India and even China, I mean, the temperature is so hot to begin with. How is it that they were able to export so much?
Well, they were able to export so much because, in fact, they had these new semi-dwarf hybrid varieties that were a product of the Green Revolution. And because these varieties could respond to water and respond to fertilizer, the yields basically tripled. So they did this in the span of like 10 years or so. And you can remember the Paul Ehrlich's The Population Bomb, movies like Soylent Green, where global starvation was imminent. And suddenly, overnight, it seemed that these things were going to be reversed. Now, here's the thing, though. We are now being able to feed 7 billion people based on this Green Revolution paradigm. That's great. But there's 3 legs of that stool that support that paradigm. Again, cheap water in the form of irrigation, cheap energy in the form of fertilizer, and a stable climate. That's what allows you to get these large yields over a very small amount of land. How is climate change going to affect that? Well, obviously it's going to affect it in terms of climate stability. You're starting to see now that you have these 1-in-100-year events becoming 1-in-10-year events. Texas is an example. Before Texas, it was Russia. Before Russia, it was Pakistan. Before Pakistan, it was France, and on and on. It's now to the point where you can almost guarantee that some aspect, some part of the world is going to be experiencing a extreme event in any one given crop year. The problem with that is that doesn't jive very well with the Green Revolution, because the Green Revolution, in order to produce that high amount, relies on a small subset of genetic cereals that are genetically uniform. And if I have 1,000 acres of wheat that are genetically the same, and I change the climate, guess what? It's not going to respond very well to that change. Why? Because I don't have that diversity built into that 1,000 acres. So any change in climate is going to have a disproportionate impact with respect to yields because of the way the Green Revolution has been set up. Does that make sense?
Yes.
Okay. The second thing is when you start looking at irrigation, water is key. I talk about water all the time in the context of ag, and I don't think people recognize that 70% of all the fresh water that's used, that we use as a civilization, goes into irrigation. It is, in fact, the biggest user of water in the world. So if we change where that water comes from, that is, if we have the increased desertification that I talked about earlier, or if we have, say, increased melting from mountains, where the ice that normally would be there is not going to be there anymore to provide us with river flow, then that source of water, overuse of water from aquifers, is also occurring. So not having that water essentially means that you're not going to have ag. So any climate pressures that are due to increased water usage and loss of water supplies is also going to have a negative effect on agricultural productivity via the Green Revolution. I know there are a lot of companies that are working on what are called drought-tolerant varieties. You've probably read about that. But there is no drought-tolerant variety that can yield as much as a well-watered variety, period. Zero. It takes 1,000 grams of water to produce 1 gram of crop. This is why it's such a huge user of water in the world today. And the productivity that you can get from irrigation is huge. For example, in rice, globally, irrigated rice probably is less than half the total acreage, but it accounts for something like 2/3 to 3/4 of the production. You simply cannot get the same amount of yield from that. The last issue is one of temperature. when you start looking at, as you were saying, how can they grow these things at these temperatures, there is, in fact, a cutoff temperature for reproduction. What we find is that when you look at a plant, it's actually the flower, and particularly the pollen, that is the most temperature sensitive. Not all parts of the plant respond the same way to a temperature change. So once you reach a critical threshold, the pollen becomes sterile, okay? And that's going to cause a dramatic drop-off in yields of corn, wheat, and so forth. If you want to see an example of that, you don't have to look any farther than the Midwest for this season, given the changes in temperature, flooding, drought, high temperatures throughout the Midwest. That's all occurring now. So it's very consistent with the vulnerabilities of the Green Revolution's ability to produce all this food in the context of climate change. Climate change is going to put enormous pressure on the food safety net and the food security system that we currently have. Not only that, but remember, you're also now asking ag to do a lot more. You're asking ag to produce biofuels from corn. You're asking ag to produce another food for another 2 billion people that we expect on the planet. You're asking ag to produce more meat for different countries, particularly in East Asia, where the Chinese are coming up into a sort of a middle-class status and they want more meat on the table. It's an enormous strain on agriculture in terms of its ability to provide the necessities for both food, fuel, and fiber in the coming years.
But having said that, what about the impact on other organisms that are dependent upon the existence of these types of grains, such as wildlife, birds, bugs, yes, all sorts of anything that we may not think about because we're concerned about the ability to produce food for ourselves, but the wildlife that's out there that is also dependent upon the growth of these crops?
That's an excellent question. And not just for the crops, but for systems that are not being heavily managed like they are for agriculture. We usually divide it up into ecosystems that are not heavily managed by humans and others that are, in the case of ag, that are heavily managed. So when you change all these things, the carbon dioxide concentration with different plants responding differently to the change in CO2, when you have these dramatic climatic changes that are going on, then you are, in effect, selecting outside of ag different species that are going to respond to that change. And as it turns out, one of the sort of groups of species that tend to respond well to sudden, unpredictable change in the environment are weeds. Weeds are great, in ecological, environmental terms, are considered to be what are called pioneer species, because they thrive on sudden disruptions in the system. So if you've ever gone out and you've dug up a garden plot, or you've had your lawn turned over, or any sort of disturbance occurs, the first thing that's going to respond to that are going to be weed species. And what we find is that with climate change, with these sudden extremes in temperature or drought or CO2, it's in fact these weed species that do very well under those conditions. So this has some ramifications. Now, in natural systems, you talked about what are called invasive species, and we should probably clarify what we mean by that. These are species that are usually non-native for a given region, and they're introduced for various reasons. They may be introduced because they make good cover for soil erosion, or they may be introduced because they're pretty. But once they escape, once they're no longer being managed in a proper fashion, they can, in fact, infest large amounts of land. So when you change CO2, one of the things that we have found consistently for a number of invasives is they respond much more to that change in CO2 than other species do. Remember I said that CO2 was could be a positive benefit for plants, but that the key was to understand that not all plants respond the same way to that positive benefit. So in the case of invasives, they seem to be responding more. And in particular, viney invasives seem to be doing much better. So things like kudzu, for example, which I don't know if you're familiar with, but certainly anyone who's listening who's been to the South knows what kudzu is.
It's everywhere.
It is everywhere. It is the vine that ate the South. The joke goes that if you left your dog on the doorstep and you have any kudzu around, your dog would be gone in the morning. So it is, one of these almost science fiction 50s, plants that can jump over your house and eat you. But it is really a noxious, invasive plant that does a great deal of damage, because what it does is once it becomes established, it reduces all the biodiversity within that particular area, because it becomes the dominant species and nothing else can grow because it will simply grow on top of it. And one of the sort of disconcerting things that we find is that, gosh darn it, this is one of the things that responds the most to that change in CO2. Here's another example. When Duke University was looking at the impacts of rising CO2 and what they call the Duke Forest System. Now, this is a system where you have an entire forest, you have standpipes going up 30 feet that are shooting CO2 into the center of a circle, that are trying to elevate the CO2 in that circle to sort of simulate what the CO2 concentration would be like 30 or 40 years from now. So it's not, just the pine trees, it's everything that's growing in the understory. So here you have a multi-species ecosystem where you're shooting CO2 in, and guess which, of all the plants that were there, which plant would you not want to have show the greatest response?
Of course, the invasive species.
In this case, poison ivy. So
oh boy.
It when you talk about, again, just to say that, yeah, CO2 is plant food and it's uniformly beneficial and everything's going to be great, not so much. Maybe there are some plants out there that you don't want to have grow that, in fact, are showing a stronger than normal response to CO2. So it's a complex issue. It's clear that there are a number of things that are going to happen. One is, again, we talked about it in terms of food security, that there are going to be these vulnerabilities that are going to occur, given what we know about the Green Revolution. But from unmanaged systems, natural ecosystems, there are going to be all these other impacts as well, one of which is going to be the increase or potential increase with respect to invasive plants. And there are all kinds of ramifications for that as well. One of the invasive species that we looked at was a grass species called cheatgrass. This is a grass species that has hundreds, if not millions, of acres within the western United States, particularly in the Great Basin between the Rockies and the Sierra Nevada. And what we found is that looking at populations of cheatgrass exposed to even just slight changes in CO2 that have already occurred for the 20th century, we see changes in growth, we see changes in their seed production, and perhaps more importantly, we see changes in their flammability. And the reason that's important is that cheatgrass is, in fact, a fire starter. It's one of those things that is very combustible. It provides the necessary biomass for fires to take off, and it's one of those things that burns very well. And once it burns, then what it does is it ends up recovering very quickly, but the native plants cannot recover as quickly. And as a result of that, it becomes a monospecific stand. Just like with kudzu, it's the thing that dominates the landscape. So our fear is that as we change CO2, as we change the climate, we're going to be changing basic plant systems, whether in agriculture or in nature, where we are, in fact, going to reduce the amount of biodiversity that's there. And we are going to be favoring many of the species, many of the weedy species that we know do not benefit society as a whole.
Well, from what I understand, especially with kudzu, it's very difficult to harvest it. And even though it has many different uses, the harvesting process is quite difficult. And it is kind of a shame that the plants that are thriving, we can't easily harvest and utilize for different reasons. But is that something that that I guess scientists are kind of reconsidering, especially since the invasive species, if you will, to just be general about it, seem to be able to go with the flow, so to speak?
You bring up a really interesting point, and let me return now to sort of the flip side. I've talked about all these vulnerabilities and threats to systems, both in agriculture and in natural systems. Let's talk about what some of the adaptations or potential opportunities are. You mentioned kudzu. One of the things, yes, it is difficult to harvest, particularly because it often occurs on hillsides and in places where it's difficult to get to. But one of the things we've been looking at, actually, is the possibility of basically the old human philosophy of turning lemons into lemonade. If you have kudzu, and there's about 9 million acres of it in the United States, but we estimate that about 1 million acres of it could be harvested. Well, why in the world would you want to harvest kudzu? It turns out that the roots of kudzu actually are very high in starch. Why is that important? Well, because starch can be made into ethanol. Now, here's an opportunity that we think is a win-win. That is, you have 1 million acres of this stuff that you know is noxious. Why not harvest it, convert it into biofuel, and use it as a positive gain with respect to energy, and then allow that 1 million acres to be converted into either farmland or into something more useful? That's not to say that we advocate planting kudzu. We don't. But it's one of the things that we think could, in fact, be converted into something positive. So, again, this is sort of an adaptation strategy. How do you take what's been given to you, and you're seeing what's going on with it, both for ag and in natural systems, but how can you use it to your advantage? Let me give you another example for ag. We know, for example, in looking at rice, actually the U.S. is one of the big exporters of rice. Not many folks know that, but it's a widely grown crop, particularly in the southern part of the Mississippi Delta. Arkansas leads the nation in rice production. And when you look at rice, one of the really interesting things is there is a weed that grows with rice, which is essentially wild rice, not the really fancy, upscale culinary wild rice that you get at Harry and David's, but it's essentially a weedy rice. And what's interesting to us is that when we look at CO2 and we look at climate change, it's the weedy rice that does so much better than the cultivated rice. And what we think that means is that, well, it has some negative connotations, obviously, because it's a weed and it reduces rice yields, but it may also have a positive benefit because why is it able to respond to CO2 more than the cultivated rice? And can we determine the basis for that? And if we can we in turn use that as a means to improve cultivated rice? That is, if we can use the weeds as sort of an example of how to adapt to what's happening with the climate, then maybe we can actually improve yields for rice around the world. That's important because 1 billion people depend on rice as a basic food crop. So, again, you're offered these threats to the system, and they're clearly there. But at the same time, you have to look at those and say, what are the opportunities that these threats present? Can we, in fact, use them in order to improve our genetic basis, or our genetics understanding of basic crop plants like wheat and rice? And we think there's an enormous potential for doing that. So, there are so many things that can be done and to allow us to adapt, to allow us to mitigate in agriculture some of the things that are happening with climate change. And that varies everything from farming more effectively to reduce greenhouse gas emissions to being able to better exploit the change in CO2 that's happening through selection of rice and wheat and other plants in order to find those varieties that will respond more to CO2 or will respond more to temperature or may be tolerant to higher temperatures. One of the things we find in rice is that rice is very sensitive to its flowers are very sensitive to temperature. We talked about pollen, sterility. What's interesting about that is it turns out that the weed pollen is not so sensitive, and it can actually do better under those circumstances. So what is its secret? What can we learn from that, and how can we take that information and use it to really shore up and to decrease all vulnerability of food security and climate change? Right now, that to me seems like the overwhelming issue. When you start looking at the effects of public health, and there are a lot, we talked about poison ivy and how it's responding to CO2, but the biggest threat to public health is actually food security. There are 5,000 children under the age of 5 die every day due to malnutrition. So how can we begin to combat that threat? We understand that climate change is one of the underlying factors in what's happening now to East Africa. We look at climate change for the droughts that are happening in Texas that are keeping prices of wheat and corn high. How can we begin to adapt to that threat? So we can do it from the ways that we've described: breeding, selection, adaptation of different crop lines. But there's so much more that we could be doing. Everything from a simple approach, can I use a phone app that will take a picture of corn growing in Kenya that has a fungus on it. Can I use that to tell the farmer can send that in, and then I can respond to them and say, okay, this is this fungus, you should spray it with this. To drip irrigation, to using water more effectively. There are so many different ways and so many different solutions that we can bring to the problem. But the issue is this. People don't understand the immensity of this problem, this challenge, if you will. They're not quite getting it. And this is something to do, I think, perhaps with how we as scientists address that disparity that I talked about earlier, the fact that the science is becoming clearer, but that the doubt and the confusion on the part of the lay public is increasing. How can we as scientists better bridge that gap? And certainly I'm open to any suggestions along those lines.
Well, Dr. Ziska, I just want to interject, if I may, because on that note, there are some comments from actually Facebook that I'd like to mention. The question posed was, what do you think the impact of climate change means? One gentleman wrote, nothing, it's cyclical. Another gentleman, Joseph, he wrote, climate is changing all the time, nothing new here. Now, global warming is another matter. The melting of the ice at the North Poles means nothing because this ice is already in the water. But melting the ice at the South Pole will be catastrophic because it is on land, and when it melts the ocean water, level will rise. Beware of the melting ice at the South Pole. Another person wrote, easy, long-term, the end of humans on this planet. Next question. And then Victor wrote, nothing interesting. It was a lot over the ages of the Earth and, of course, the extinction of the human race. And, people are clearly, they just kind of feel that, okay, there's been so much said about global warming, climate change, that it's the end of the world as we know it, and what else is new? And that's kind of the general feedback that I'm getting from the folks today on Facebook. Once again, when you speak to someone who is a scientist who has spent so many years researching so many different areas that are affected by the increased temperature, then you can really piece things together. It's just, unfortunately, you have people that have been out there that have been disseminating information that is not necessarily accurate, trying to just basically raise awareness by inflicting fear.
Well, the goal of scientists is not to inflict fear.
No, certainly not.
This is not the end of the world as we know it. Sorry to disappoint those of you that think it is. It's not. At the same time, I will also point out that while it does occur in cycles, this is man-made. This is human-induced. There's no question about that. The climate will respond to CO2. Doesn't matter if the CO2 comes from volcanoes or whether it comes from human activity, it will respond for the very basic physics that I talked about earlier. So the question then becomes, rather than looking at it from the either extreme, it is that it's not happening at all and it's all a plot on the part of thousands of scientists to get more research money. By the way, I'll just interject that our research budget has been cut every year since I've been working on this issue. And if there are lots of money to be made on this, I haven't made it yet. Maybe my check's in the mail. I don't know. But so far that hasn't happened. Maybe I'll get lucky. But it's not a conspiracy on the part of scientists to get more research money. Trust me on that. You can talk to anybody about it.
Oh no, I certainly don't feel that way. I'm just saying that there are many people.
I know. I'm trying to address the person who mentioned that. And on the other extreme, it's not the end of the world. The CO2 actually has been this high in the past. Temperatures of the Earth has warmed accordingly for it. But how do we, as a society, how do we deal with this issue? And the best way, I think, to deal with this issue is to focus on the science, and particularly on the scientific concerns and the scientific ideas that we can bring to the table that will help us to adapt agriculture, adapt our systems, adapt the way we manage ecosystems so that they can be sustained over the long run and decrease the vulnerability to climate change. So, and then there's an enormous amount that we can do in that regard. So, this is sort of the best information that I can bring to the table. If there are those who deny it, who say, no, climate change, no, just human beings don't cause it. It's the sun. I've heard so many explanations. It's the sun. It's bad thermometers. It's blah blah blah. Prove it. Do the experiments. Tell me I'm wrong. This is the beauty of science. Trust me. If you get 12 scientists in the room, you're going to get 12 different opinions on something. The fact that 98% of all climate scientists agree on this, they may disagree as to the extent and the pace, but they agree that it's going on. That's phenomenal. That doesn't happen very often. So this is the thing that if you're a denier, great. Go do the science. Show us we're wrong. So far, that hasn't happened. We can monitor sunlight. It's not that difficult to do, and there's no increased output. The sun goes in cycles, but there's no increased output of the sun that can explain this. There's no increased output of cosmic rays that can explain this. There's no elves that are working in underground mines that are causing volcanoes to erupt that can explain this. It's a simple physical explanation based on the properties of CO2 and water vapor. And we don't get that from some sort of magical liberal climate book. We get it from the Handbook of Chemistry and Physics. If you know something different, for God's sake, publish it, because frankly, I would rather be doing something else. There are so many other things that I could be working on, that there is so much more money associated with those things. So this is the issue that we're stuck with. We have the science. The science is very clear. How can we bring that science to the fore in such a way that it isn't a political issue, that it's something that we can look at and address in a rational and reasonable manner, and do so in a way that's going to improve food security in the context of its vulnerabilities, the vulnerabilities of the Green Revolution and climate change, that will help us to manage ecosystems better, that will help us to manage invasive species better, that will help us understand the links between climate change, plant biology, and health. There's all those things that we could be doing. So, yeah, those are the issues. Those are the things that we want to talk about. It's very difficult to have a conversation with someone if they could just keep saying no all the time. If you have a 4-year-old who insists that the sky is polka dotted and you keep saying no, it's not, and they keep saying yes, it is, then you can argue until you're blue in the face. They're not going to change their mind because they believe in a reality that doesn't have a basis in the physical and natural laws that we know about. There isn't much you can do for that. So, but if we can bring the conversation to a reasonable and rational level, if we can look at the science and what that science tells us, I think we can do a lot.
Now, speaking of which, Dr. Ziska, is your research available to the public for review?
Yes, yeah, of course. Everything I publish is published in the public domain. Where
can anyone review the information? Because we still have people, there's a comment from Twitter, Peter Tambakis, who said, he responded, he said, global warming was scientifically proven to be a hoax. And I'd like to invite Peter to take a look at your research and then further comment.
The best thing I would suggest is just to Google my name, and then you'll find a number of hits with different PDFs that you can do. If you type my name in USDA, you'll go to the website for our laboratory. The laboratory has the different scientist profiles. Those profiles have a list of the PDFs that are available for the different papers that have been published.
Thank you. Now, moving forward, with regard to the existing crops, what are scientists trying to do to, I guess, the address this situation with the potential possibility, and I'm trying to be very delicate with this, the potential possibility that if things continue to go as they are with the temperatures rising, and if the crops are negatively impacted, are they doing anything where the invasive species can actually be utilized? Is that something that they're really trying to work into the equation?
You mean where the invasive species per se can be utilized as a crop?
Yeah, because it seems as though, especially kudzu, and I'm just using kudzu as an example, there's so many different things that can be done with kudzu. It's just, as I said earlier, harvesting the kudzu is quite difficult.
Yeah, no, I
quite
understand
difficult.
that.
Is there anything that they can do to either I'm not an expert, I don't know, but I'm just asking, is there anything that they can do so that maybe they can possibly utilize kudzu in some way?
I think what you can't really use it as a food source per se. It's difficult to get to. It's not something that you're going to get the yields that you would get from some of the cereals. You can use it in the sense of using kudzu as a source of starch. It's in fact used in Asia as a thickener for different sauces and soups. I suspect that it was probably brought over at some point for folks that had a restaurant or some kind. In fact, I think there's an apocryphal story about a large kudzu plant growing out of a Chinese carryout restaurant somewhere in Connecticut. It's been there, for 50 years.
Oh, wow.
So, you can use it. It does have some uses for it, and I think there was also a report talking about its potential impact as a cure for alcoholism.
Wow.
So understanding that there are other uses or potential uses that have not been discovered yet. One of my favorite quotes is that a weed is just a flower, just an unloved flower. You just haven't found that use for it yet.
Well, it's like with dandelions. I mean, the Germans, from what I understand, the Germans are genetically modifying the dandelion, and when I heard that, I thought that was outrageous because most people can't stomach the sight of a dandelion in their pristine lawn, but yet because of the situation with the rubber trees being diseased, I don't know what the current situation is, but I remember when I was doing the research, the rubber trees they were being infected by some type of disease. German scientists were trying to genetically modify dandelions so that the sap would not thicken so quickly, and they could use that as in place of rubber.
Right.
I don't know where they stand with it now, but I just thought it was interesting, something that most people just don't want anything to do with. The Germans were taking that particular plant and trying to do something positive with it.
That's exactly right, and this is one of the things I was talking about earlier in terms of our ability to make lemonade out of lemons. That is, if you're given this change in demographics, that is, rising CO2, temperature, extreme events, favoring a certain group of plants over what may not be traditional or what you're used to, you can certainly look for new uses among those plants. But here's the thing. When you start looking at global agriculture, and this was actually covered pretty well by Jared Diamond in his book, Guns, Germs, and Steel. If you look at global agriculture, one of the things you find is that there's only a handful of plants that are really available globally as a food source, and these are all cereals. So I think there's something on the order of 300 to 350,000 plant species, roughly. Of those 300 to 350,000, there's only about 100 that are edible, really, that can be used consistently. And of those, there are probably about a dozen that provide 75% of our calories. And of that dozen, 3, corn, wheat, and rice, provide 50% of global calories. There's simply, to the amount of arable land that we have and the amount of resources that we have, those are the things that you can get enough yield on that will provide sufficient food for the globe. There aren't any other plants right now that we have that can do that. So that's what we're stuck with. And the question is then, how can we adapt? How can we improve those plants to be able to respond and to maintain food security in a climate changed world? And one of the things that we talked about was, there are wild populations of wheat, of rice, and so forth that, at least in the case of rice, may be responding better than the domesticated crop varieties. And if they do in fact respond better, understanding why they do and predicting what those genes are and how we can get those genes to work for us in a more positive way, doesn't take genetic engineering to do that. It just takes old-fashioned, plant breeding. We can do that in such a way that, in fact, we might be able to, again, turn lemons into lemonade.
Unfortunately, folks, we are out of time. Thank you so much for tuning in. This has been June Stoyer with the Organic View Radio Show. Have a great afternoon.